Okay, I think we're recording now. So hi everyone, we're just welcoming you to the end of year review for the Performance Hallway Hangout. We're joined by some of the folks across the WordPress performance team today, where we're going to be reviewing the WordPress performance improvements throughout 2023. We're going to have a bit of a retrospective, sharing field data for those performance impacts across the team. We're also going to be just having a discussion around the interpretation of these metrics and see what else comes out of the presentation that Felix is going to share with us. And then after that, we're just going to have a look ahead to 2024 plans to see what we feel as a team we should be focusing on. We're going to record this session and I will kindly hand over to Felix. He's going to run us through a presentation just around those 2023 results. I think most people who have joined this call know who everybody is. So I don't know if anyone feels a value in sharing that, but predominantly the folks already here are working on the WordPress core performance team. You can find us in the Make WordPress Slack space in the core performance channel. So I guess, Felix, if there's anything else to add, please feel free.
No, just are the slides visible for everybody?
Yes, they are. Thank you.
Okay. Yeah, I'm gonna try to go over this deck in maybe 10 to 15 minutes, but the whole deck will also be publicly shared later, so anybody can take a look at in their own time. So the focus of this deck is essentially to share field metrics and kind of try to tie it back to our specific efforts in this year and how successful they were in the field. Quick explanation here on field metrics. Those are the metrics for example, the core web vitals metrics measured on actual websites. And this is based, there's various ways to do that, but the way that this is done here is using the Chrome user experience report data, which is a public data set. Anybody can have a look at that data and query it, and that essentially, records the performance data for sites of all the Chrome users where they have opted into this. And those field metrics are essentially real user metrics as they are perceived by users. So that's different from lab metrics, which is what we are typically doing while we're developing things, which is just running a benchmark, like, I don't know, in GitHub Actions or on your local machine or so on. And the important thing about field metrics is that they represent, well, how the performance is how the performance of a website, for example, is perceived at scale across all those different systems and website and environments that real users visit those WordPress sites. That is different in lab metrics because, as I said, you only typically measure on one machine or two machines or three machines, but that just doesn't represent the way that real users actually consume the web. Field metrics are unfortunately influenced by myriad of factors. So the downside of field metrics is that they are not an A/B test. That's the best way to describe it. You cannot just, it's impossible to say, here the field metric went up and it was because of this exact thing. It's impossible to say that because those metrics are recorded, like they're influenced by so many different things, like where is your website hosted? Where do your users come from? Are your users predominantly on weak mobile devices or on high-end desktop machines? Like that, all those things affect how the actual performance of websites is perceived in the field. So then there's even browser improvements. Maybe a browser ships some new feature which makes almost every website a little bit faster, and then we can't just assume that came from a specific WordPress change, for example. So it is important to interpret those metrics. It's not just, oh, here's a number and it means we did good. Like that's just not how it works. but despite all that, the field metrics are really the only way for us to see how beneficial our performance efforts really are. Because again, the lab efforts metrics are important to determine whether change seems to make sense as we work on WordPress. But in the end, we have to always validate how does this translate to a field improvement. I'm not going to go here too much into detail. The core web vitals are LCP, FID, and CLS. There's a lot to read up on that already. And my only reminder here is that a single URL will only be qualified to have good core web vitals if it's good in all three of these metrics. So not if a site has great load time performance, which is LCP captured by LCP, but very slow, delayed interactions, like FID, it would not have good FIDs, then it also doesn't have good core web vitals. Here's just a note on the source again, where all the metrics from this deck will come from. But now let's actually dive into the numbers. And well, first of all, the numbers are great. I'm really happy to share that the web vitals passing rate for both mobile and desktop this year has improved by more than 8%. That is, and little disclaimer here, those numbers, 8% doesn't sound amazing, but it actually is amazing when you think about this is across all WordPress sites, which we know is millions and millions of WordPress sites. Overall, the passing rate for those core web vitals has improved by more than 8%. And it's even more significant when we consider where the baselines are. Like we're only at, for example, on mobile, we were only at 28% passing rate a year ago, and now it's over 36. So that's, when you think about that relatively, we improved, well, I think we improved by more than 20% relatively. That's massive. And also in the previous year, we already had also very good improvements, but we were able to exceed them this year. So that's great. And here's just a quick visualization of how those numbers changed over the course of this year. I marked here one spot where it went down a bit, and that's most likely, again, this is interpretation, but it was visible, I can share here, it was visible that this drop between March and April this year happened on almost every dimension. Like we also look at, for example, other CMSs like Drupal, Shopify, and so on, like all of them had this drop between those 2 months. And that basically suggests that it was a general change that led to this drop more than a specific CMS change or something. So, and it was there was an actual LCP algorithm change, which means it was different. The way that LCP was measured slightly changed, and that led to a LCP passing rate decline across the entire web effectively. So that is not something to worry too much about here. For the specific metrics, we can see that primarily LCP improved significantly on both mobile and desktop. That makes sense because that was also our focus this year. So I would say we did pretty good. It shows the one area that we focused on the most as part of the performance team is also the one that saw the largest gains in this year. So that, I think that speaks to our success as a team. Another extra focus that we had this year was time to first byte improvements. There was also good improvements to see here. I just wanted to share time to first byte is not a core web vital, so it's not as significant as those 3 metrics here. But time to first byte has a very, very low passing rate in general overall. As you can see here, like the passing rate is only like around 20%, which means it's the lowest performing metric of all metrics that are captured in the field. And time to first byte is directly a part of LCP. So it's essentially the server-side performance, while LCP captures the overall performance, so including client-side performance and server-side performance. So as such, improving time to first byte directly contributes to improving LCP, and that is why because of our LCP focus, that time to first byte focus was a partial goal this year as well. Let's look now at specific releases. So those numbers are a bit more specific in the sense that to get those results, what we did was look at sites that were on the older release. Like in this case here, for example, the previous release was 6.1. So we were looking at sites that were on any 6.1 release in a specific month, in this case March. And then we compared the sites with the same set of sites that was on WordPress 6.2 a few months later. And we did there's a little gap here between those months. That is mostly the case that because we wanted to get to a good size data set, so that the data is more meaningful. Of course, there's trade-offs between doing that in the different ways, but we chose that one for now, and we can see here that the time to first byte and time to first byte had significant improvement, especially on desktop. LCP on mobile, this number is really like, it doesn't matter. It could also be minus 0.01. Like this is too small it is essentially remained the same. Interesting though, it is very interesting that for desktop, the time to first byte and LCP went up a lot, but for mobile, not so much. I don't know, but we can talk about this later, what we interpret from this, but that's just an interesting finding here. 6.3, very different. 6.3 had more of a client-side focus, so we worked a lot on the, we got those fetch priority fixes in there, and also the emoji loader improvements, and those there was already a post a few months ago that showed some of those enhancements. So those really significantly affected LCP. So LCP went up a lot in this release. On the other hand, I guess maybe because we didn't focus as much on time to first byte in that release, it's interesting to see that desktop declined quite significantly. At the same time, mobile time to first byte still improved significantly. It's I don't know what to make of that, really. We can talk about it later. It actually has a higher improvement here than in the previous release on mobile, but on desktop, it's much worse. So that's just interesting. For 6.4, we don't have metrics yet, so those will become available probably next week, and I plan to add them to this deck once they're there. Also worth sharing that what is the adoption of those releases? And we have those numbers available on WordPress.org as well, but for consistency with the data set, we took those from the same data where all the metrics come from here. So those numbers are essentially, those numbers are not just, they're all based on November data, and they're not just how many sites use 6.2, they're, in this case, how many sites use 6.2 or newer, because that is what we really care about when we think about how many sites have the improvements from that respective version already available. And this is just good to know and have in mind, because we have to also consider that this means more and more sites will update to these versions in the future. So it's always great to know that all the great efforts we did and landed in WordPress core this year will still gain more and more improvement next year as the adoption of those versions continues to grow. Let's look a little bit on the overall web. I mean, just the overall web, right? Like so to do that is what we want to look at is how much does WordPress core web vitals passing rate improve versus how much does the passing rate of all the sites improve that are not WordPress on the web. And here's this comparison. You can tell at first glance, WordPress did much better than the rest of the web in its improvement. It's worth noting that the rest of the web overall has a much higher passing rate, but WordPress is catching up, and that's I think the main thing that we should be proud of now. We've made more than double the passing rate improvement, and that's quite significant for mobile. We can also, this is just a little calculation here for us. We can also make some guesses on what is the WordPress impact on the overall web passing rate improvement. And with a very basic formula like this, to look at the overall passing rate web improvement, which for mobile, for example, was 5.35%, we subtract the improvement that came from non-WordPress sites, and then, which was less in this case. So we can basically summarize that WordPress amounts for 1.67% of CWP improvement for the entire web, which, I mean, again, 1.67% doesn't sound like the world, but it is for the we're talking about the entire web. That's a lot. So I'm going to close this presentation with a few 2024 considerations, because we need to start thinking about what we're going to do next and what we're going to continue doing. One of the probably the most significant changes for performance next year is that the FID metric, which we haven't focused on at all for now, because it has been, the passing rate has been super good, so there's nothing to focus on. This FID metric will be replaced with a new metric called INP. If you have not heard about INP, I would encourage you to read up about it. So this means that this FID metric, which had very high passing rates generally, is going to replace by a new metric, which may affect how the overall core web vitals passing rate is perceived. And just to very brief summary is the INP metric provides a more accurate representation of user interactivity than this FID metric did. So let's look at what this means. All these numbers are, again, from I think this is from October. So it compares you can see very quickly how FID is super good. There's nothing to worry about. But mobile INP specifically is a lot worse than the respective FID entry. For desktop, it's not that much less. So that's maybe not so much to worry about. But mobile INP is a lot worse, which means by definition it will reduce the overall CWP passing rate. Of course, next year, probably the values will have already changed, hopefully improved further. But this is just a representation of what would the core web vital passing rate of WordPress and non-WordPress look like if INP was already part of the CWP metrics today. And we can see there is a significant decline here in the passing rate, 3.5% for WordPress and more than 7% for non-WordPress. So as a little consolidation, or how do you say that? Consolidation, I guess. We can say at least WordPress is not seeing as negative effects as the rest of the web from this, but there is a significant decline here. So that means that essentially part of next year's goal sort of will be to, I guess, catch up on this drop off. Whether we do this through INP improvements or continued LCP improvements, it doesn't really matter, I guess, from the metrics perspective. But we're gonna have to catch up a little bit on the loss here next year. So if we just remember the current 8+% improvement we landed this year, I'm just going to make an example. If we were going to do get to the same improvement next year, it would effectively only be something like 5.5%, because we have to take into consideration this decline. Another thing to look at, potential learning from this year, and that's something I would really like to discuss more, is the time to first byte improvements, which we focused on this year. They seem to have made less of an impact in the field than LCP, specifically the 6.3 release, like I mentioned, which had this more of a client-side focus, made a significant LCP improvement on mobile, at least, while 6.2 was really, there was no change on mobile. For desktop, they were both sort of similar. And time to first byte, like I already mentioned, it was for desktop. It very much represents our expectations, but for mobile, it's also pretty much the same between both versions. So there's probably something to discuss here. What do we take from that? I mean, it looks overall, I would argue that the LCP improvement from the client-side release has been higher, but yeah, we have to see what that means for our time to first byte efforts. I'm just putting this here as a summary for potential conclusions. Whether those are actual conclusions is left to discuss for us. And that's it for the presentation. I'm happy to keep the slides up as we're maybe want to discuss a few of those items.
I had a question about the mobile INP being so much worse. Is your just like intuition, or my intuition, I guess, is that has to do with low powered mobile devices? Is that what the thinking is? Like interactions are slow because people have low powered devices, and that's why it's good on desktop. Do you have any insight on that or thoughts?
I'm not sure. I'm sure there is an answer we can find fairly quickly reading about it, but yeah, like it's definitely a pattern that you see everywhere for INP, that the mobile passing rate is the one that's a problem, where somehow on desktop it's still not a big deal. I mean, there's a good chance it is because of the lower powered devices simply. I mean, I guess even me personally experience a lot more jankiness on mobile when I browse random websites than on desktop. I guess it makes just a bigger impact, I suppose.
Yeah, I mean, I suppose it could be network conditions as well, but I was just thinking, like, for interactions, it's probably largely devices that don't have enough horsepower, memory, CPU to like respond effectively, and everyone's building for not targeting those devices.
What would be the fix? It's like super low res images, or what is how could we support underpowered devices in a way? What could we do to mitigate that?
I think for INP specifically, it's a lot about JavaScript.
Yeah.
INP specifically is it's about the amount of JavaScript, but it's also about how the JavaScript is executed. Like things like using a worker thread comes to mind. That's one of the top things that can improve INP. WordPress doesn't have support for workers, so maybe we want to add support for that. That's just a quick reaction of that. I don't know if we want to do that, if we're realistically going to do that, but that's could be a good opportunity. But it's really a lot about the actual JavaScript code. So it's about reduction of JavaScript code, but it's also about optimizing JavaScript code. That's where a lot of the INP issues come from.
That sounds like something the plugin reviewer, some analysis of JavaScript code in plugins, looking for performance stuff in there. Maybe even is there any optimizer tools out there that potentially we could run over code and make suggestions to improve JavaScript, and potentially do that? I don't know if there's any tools that would around, just spitballing, as they say.
I'm not sure. I don't know if anybody else has a good response to that. I'm not sure.
Yeah, I mean, I think part of the challenge is it's not just static analysis. A lot of these like INP issues don't really come up like when you're looking at your code or looking at one block of code. It has to do more with what happens in the field when you have a lot of different JavaScript interacting on the same page. So I do think that type of testing is a good idea. I just don't know how easy it's going to be to implement for this particular metric. The one other thing that leads to bad INP is really complicated like layouts, like DOM complexity. So really complex DOM layouts and low power devices don't mix well. That is something we potentially could address, although I don't know if that's our problem.
And also it's likely to be in the themes and front-end plugins, which is something we can't really get at very easily. So yeah.
It's also a lot about the combination of things. Like if you have shiny animations here and there, and three ad providers and tracking and all those kinds of things on your website, those things, I think they add up. So there's basically a competition for the few resources that a low-powered device may have, and all of that together, like if you have too many of those interactive features, then it becomes more visible. And I guess that's what happens on real websites, which use a ton of features, where if we work on a single plugin, we may not even notice that something is a problem, because it only becomes a problem when combined with other projects.
So I guess I don't think we can go this route, but one of the approaches would be to have a common framework for animation and various things like that is baked into WordPress, where all the other systems just instruct, rather than have 4 animation frameworks, one from each of the 4 sliders you got on your page and the theme, are all dropping animation frameworks on the system. Whereas if we installed a common, a standardized one, yeah.
But one thing that comes to mind in that regard is maybe the interactivity API, which is very, very new. It's not even really publicly available. But that interactivity API is, I think, maybe the first how do you say, the first kind of WordPress core's own JavaScript API that it's just starting to be rolled out now. But that would allow plugins to use a core controlled API, write a lot less JavaScript because it's primarily controlled by HTML directives. And yeah, and we could see maybe there are some ways that we can improve INP through the interactivity API. Of course, that relies on adoption of this API. So I think this API is a potential great opportunity for the future.
Yeah, and if we've got static analysis in the plugin checker, we could look for opportunities where those should be, port to interactive API type instructions.
I was also curious to what extent the prevalency of cookie consent pop-ups that we're seeing all over the web are contributing to INP scores, just like generally being low. And if there's some opportunity for WordPress to have like just a standard cookie consent
one. Yeah,
that is optimized.
I would think that's a low-hanging fruit, because every site now needs one, or 50% of the sites need one. And we could build it in a way where it was reasonably extendable for the plugins. So the plugins would be modifiers of rather than recreators.
Potentially. I think the tricky part there is that a lot of the big services that provide cookie consent have their own JavaScript that they just want you to drop on the page because they have no idea what the framework is. So integrations would maybe be more challenging, but that doesn't mean it's not possible.
Yeah. A simple basic one that works.
Right. It also might lead to more websites adopting cookie consent forms that don't currently have them, which could have the opposite effect.
Could it be done in a way where it doesn't actually get penalized in the stats?
Yeah, it'd be worth looking into. I think if we did one, I think that's the approach we would want to take, is like, let's have a neutral impact in, compared to no consent, right?
Mm. Do you think that would be a case of analyzing the top 20 cookie consent plugins we've got in core and seeing if any of them could be made into a Chronicle plugin and do that rather than build it from the ground up.
I mean, yeah, potentially. This is it's I guess the tricky thing was with those cookie consent banners is building something into core will, I think it will still require extensibility, because sort of similar to how the privacy policy feature that was built several years ago, those things are very much driven by legal requirements, which may differ between different regions and so on. And then, so there's no way that WordPress will be able to cater for all of that. It just has to provide a good foundation. So I guess yeah, extensibility is critical. Extensibility will be critical for this. At the same time, if the extensibility is made to be, you can do whatever you want, then it's maybe also end up not improving the situation, right? Like if all those third party, if I don't know, if there's maybe certain third parties that cause more of those INP problems with their cookie consent banners, then I mean, they're still going to work the same way that they do today, I guess.
Just conscious of time, we want to focus around any other interpretation of these metrics, and obviously make sure we've got time to look ahead to 2024. Got about 25 minutes left, so if there's any other comments around this presentation deck, that would be good to go through.
Just one thing is there was no tie back to numbers, to costs, so the cost of search engines crawling going down, the saving value there, the cost saving of hosting companies because they're having to do less work, or are they doing more work? Is it costing them more? I just wondered if there's any way we could grab or attain some dollar values against what this actually means in real world, to sort of help drive the point home of why it's important.
I mean, we can try to draw general conclusions from the numbers, but I think mostly, I mean, to get real numbers, I think all you can do is sort of case studies, right? Like maybe there's a certain hosting provider that would be happy to share with us rough, like, here is how much the LCP improved and what that meant for our revenue or for our cost. But I mean, I don't know, I think those are usually more specific case studies that can help us draw those conclusions. Like, I think at scale from this overall data for the WordPress ecosystem as a whole I think it's difficult.
Maybe the trick would be to do a call for a case study. As we've done this, is anybody prepared to stand up and do that? Because that's good publicity for them. So maybe they will stand up, do that for us.
That's a good idea. Well, one of the things that I was curious about from your second to last slide is just sort of the idea that we get more benefit from focusing on like front end LCP improvements than from the underlying time to first byte improvements that then also like drive LCP improvements. And I'm mindful of, I mean, in some ways, like this was one of my initial gut instincts, like the beginning of the year, is that like the websites that tend to really care about performance, they fix their server side rendering performance, or their time to first byte issues by just like not hitting the WordPress application at all, right? Like it's full page caching, it's really aggressive object caching, and anything that we're doing at the application level, while helpful, is, you know, a drop in the bucket compared to what people can get out of, you know, other strategies, right? However, I'm also mindful of the fact that, like, particularly with 6.3, we had two really big opportunities that were pretty easy, low-hanging fruit that had a big impact on client-side LCP, which is the removal of the emoji loader script, which is like a big blocking script, right? That I don't know we have any comparable opportunities still to try to hit, other than potentially getting rid of, you know, jQuery by default in a lot of places. And we also had, you know, the addition of fetch priority and removing lazy loading from some of the LCP images. So I'm curious, while yes, like focusing on front end LCP improvements does seem to be like the easier, or have more leverage to it in some ways in terms of driving improvement, like where do we have opportunities that are you know, of similar scale that would make sense? Or do we start to get into a situation where now, like, driving server response time improvements could have just as much impact as client side?
I mean, I think from my perspective, the difference is a little bit that most of the client side improvements we have done, and that come to my mind right now, are larger efforts than whereas improving server side performance is cutting 1%, one millisecond off here and there, cutting another millisecond here and there, and it adds up over time. So it's a lot of little things versus a few big things, I guess. And I mean, there may certainly be a point where we have no idea what else to improve on the client side. But I think there's a few things. I mean, you have already mentioned in the past few weeks you're working on the image sizes attribute, like is one of them, right? Like we're optimizing how large images are loaded, or continuing to optimize how fetch priority and lazy loading are applied. I mean, that's not going to necessarily improve more vertically, but it's by making that correct for more pages, it's going to give this benefit to more websites, which will also drive up the passing rate of those sites more.
Right. Even revisiting ways for more websites to make use of more modern image formats, which I know has been a challenge in the past. Like,
one thing that I guess is, from my perspective, the main indicator is when we look at mobile in this slide, is that's where the big difference is happening, and it also makes sense when you looked at LCP together with time to first byte. Like the time to first byte improvement on mobile between both releases was roughly the same, but the LCP improvement in 6.3 was a whole lot more, which that kind of confirms that it probably came from those client-side improvements predominantly. At the same time, on desktop, that looks very different. Desktop, we had this time to first byte improvement more visible. That to me is actually maybe something that I don't know. I've been thinking about why does the time to first byte improvement is so visible? Why is that so visible on desktop but not so much on mobile? One theory I have is that is maybe because we develop on desktop, we don't develop on mobile, and we build those optimizations always benchmarking on a desktop machine. That maybe we're working on things that make more impact on desktop, and the other consideration is that mobile devices, again, are more low powered, have typically worse network connections because they're not used in Wi-Fi and so on. Like those maybe it's just because for mobile specifically, those time to first byte improvements that we are making plays a very minor role.
That's what I would suspect, that network conditions have a bigger proportion of the impact on time to first byte for mobile devices.
Right.
So even with the improvements that we make, it's not enough to make up the difference to get the numbers into the good.
Right. Which suggests that basically the most of the effort we've been doing is specifically improving desktop time to first byte, but not so impactful if we want to improve mobile time to first byte.
Well, but one thing to keep in mind though is that you're measuring what percentage are getting good scores, not what is the actual value of time to first byte and the change in time to first byte as a actual metric, right? So like it could have been that we made just the same amount of improvement in time to first byte for mobile users as we have for desktop users. It's just not enough to go over the threshold to have more into the passing rate.
I actually did. I mean, this is not in this deck, but I have looked at those numbers at some point because I have in the past assumed the same thing. But
okay.
When we did look at when you look at the P75 values of all the individual origins, like or if you aggregate them somehow in median or something, it's still there were major improvements in similar ways. Like I had the same hunch in the past where like, oh, but what if we improve performance just not above the threshold?
Mm-hmm.
And I think I'm sure there are improvements on some segment of sites which would be visible in those numbers, but at the overall scale, it's still not visible, or not more visible than in this improvement.
Okay, I wondered if now might be, with 15 minutes left, a good time to just discuss what's coming up in 2024, if folks feel that that's a good time, unless there's anything else to go through on the slide deck. Cool, okay. All right, we'll move over to 2024 then. I guess it's just kind of an open floor, really, to if people have ideas and suggestions. I know some folks here have been getting involved in, putting forward suggestions. So, yeah, I guess just open it up to anyone who's got suggestions for 2024.
You were talking about images earlier. I just wondered, does the amount of images in the media library impact just going through the file numbers? So if someone changes themes or something like that and there's orphan image sizes left around, is this something we should be having a tool to help clean up? You could set image sizes on for images to be generated in WordPress, yeah, and you change the theme, you turn a plugin off, those images are left behind, the custom sizes are left behind. Does that bloat on number of images in the file system have an impact on fetching the image, finding the images next time? I don't know. And if it does, would a simple tool, part of the maintenance tool, the ability to remove images that are not current?
I think some of the regeneration tools do that, like the regenerate thumbnails. They'll remove the old images. The challenge with removing old images is you can have URLs that still point to those images in your content. It doesn't get updated, so there's a risk in doing that. In terms of whether it slows things down, I think most people have their everything in folders, dated folders. But I guess if you had everything in one giant directory, that could have a potential effect. I think if it's broken into directories, probably pretty minimal, the amount of time that it takes the system to load the file or something.
Yeah, I don't think the file loading it would be the issue. The one place that I would be maybe have some curiosity about is if we've got a bunch of attachments in the attachments, like in the post director, like a database, and when we're doing lookups for how many intermediate sizes do we have that we can use to fill out like source set and some of those sorts of things. Like maybe there's places where we could like eliminate some of the source sets, but I suspect that's a really, really small
I suspect as well, but I thought I'd mention it.
Yeah, it's worth looking at.
I think it's most. I think those remaining images are mostly in about. I mean, they are wasted. They're wasting storage space. I would argue that's the biggest. That's the biggest issue, and then that can incur costs, and that's the biggest issue. I think for the performance of the end users, I would doubt that it has a notable impact. Because whenever you load an image URL, you already have the URL. You don't need to look through the directory or anything like that. So I don't think it would make a big difference there.
Anything else anyone has top of mind for where to kind of go next in 2024?
I like the idea of the interactive API, getting behind that a bit.
Yeah, I think we should try to think for next year, what can we do to improve this interactivity, not just the interactivity APIs specifically, but like how can we facilitate WordPress sites having faster, more responsive interactions, because of this new metric that is being introduced, it's more significant, but also because the metric is performing pretty poorly. So I think while my personal perspective is that while this year we have been mostly focused on load time performance, I think next year we should try to split that a little bit between the load time performance, but also start thinking about what can we do about improving interactivity. And this interactivity API I think is a great opportunity, as we have already mentioned.
I think any other like intentional research we can do to sort of help diagnose what leads to a lower IMP passing rate. I mean, we threw out a bunch of really good hypotheses, I think, earlier, and some options for things that we might be able to do to fix those problems. But I don't know that we have a lot of confidence in knowing that like the things we think might be problems are actually the problems.
Definitely, yeah, we need to do some more research on this. One other thing I'm curious on what anybody's thoughts on those time to first byte. What do the time to first byte numbers? What should they mean for us, for our efforts? I mean, we have been. I think this year we have been very much focused on improving time to first byte in core, but like of actual core performance. There maybe, especially thinking about the mobile representation there, are there other ways that we should maybe try to get time to first byte move forward? Like, are there, I don't know, I'm just thinking out loud here, like what about building APIs or enhancing APIs in core to provide more guardrails to don't do the wrong thing for plugins or so on. But similar to that would be, there's all those different components. There's like plugins, which obviously impact time to first byte a lot over what core does. You could argue that even those changes may not be that impactful in mobile, though, because there's still the network connection component and hosting quality and lack of page caching, maybe. So there's maybe lack of page caching is something that we can somehow invest in. Is there something that core can do better there to facilitate caching for more people? Are there ways to unlock caching is there ways to maybe unlock caching for sites that don't have a host that provides that feature? Like, are there other ways that are maybe not as good, but at least good enough, like that kind of thing?
We had talked at one point earlier this year about trying to use the
SQLite. Are you talking
the
about
SQLite, database as an object cache for sites that don't have a better option? I don't know if that's worth thinking about again.
That could be one. I mean, I guess the I really like that idea, and I think that may be worth exploring. On the notion on this on the page, that would mostly be for object caching, though. I don't know if we could we use it for page caching. I'm not sure.
I don't know, but yeah, for object I mean, for more persistent caching for sites that don't have it now. Yeah.
Right. Yeah. The thing is, I guess the thing is, then the persistent object cache is mostly helping with avoiding database requests, which can be significant, but also not necessarily are not necessarily that significant for overall performance. So I would argue that, like, I guess I think from this from this perspective of mobile sites not doing so well, I think that the full page caching would be more beneficial to focus on rather than object caching.
Oh, sure. Yeah. If we can avoid people hitting the application altogether, that's always better than making the application faster. But it still like may have some significant improvement. One of the things that I noticed yesterday, I was looking at full page caching yesterday with the Core Web Vitals, like the technology report dashboard. And I was surprised that most of the really popular WordPress caching plugins that are in that like list of technologies, their time to first byte scores are not beating like the general WordPress time to first byte numbers, which is like, to me, seems counterintuitive. So I wanted to maybe dig into that a little bit more and see, is that because the people who use those are already suffering from like way lower than average? Is it because those plugins that generally come to the top of the list when people are looking for caching plugins are actually not doing the right things? Are they just misconfigured often? Like, it's just like, it seemed really curious to me.
Have you I don't know, were the plugins you looked at plugins that were specific to having this full page caching? Or because I'm thinking a lot of performance optimization plugins offer that, but it may not be enabled by default.
It could be that they're not turned on. Right.
So maybe
I was just thinking,
maybe
I think of them as full page caching.
Sorry.
Yeah. So I think of them as primarily full page caching plugins, but they may not, it may
I'm just thinking
be
if
that people aren't using them that
one
way.
of those plugins that has a ton of options. I'm just thinking, well, maybe 80% of users don't even enable the object of the full page cache or something. Right?
One other thing that can happen, Joe, is you get a geographical bias. Like if the plugin is super popular in a region where there's slow internet, then that can bring, like we've seen that with certain hosts that operate in a certain region, and then they have really poor CWV stores, but it's not their problem. It's actually their users that are the issue, the reason. You can actually break down on the settings page on that CWV tech report. There actually is a geographical thing, so you can mess around with that a little bit to see if.
Okay, I'll take a look.
It's hidden in the settings page.
Yeah, that's smart.
I wonder if there would be a way for us to, can we somehow come up with a reliable, or at least more reliable way to segment sites between whether they use a full page cache or not, or maybe even the type of full page cache that they use? I think, like in the field, I think it's very difficult.
Right.
Very difficult to detect that. I guess we would maybe we can.
Most have a string in.
Sorry.
Most have a comment string in them. Most, cached by.
Or I wonder if just even the header that is returned in the request would tell you if it's cached or not.
Yeah, most of them has hit or miss header in them, just for checking whether it's a hit or miss. We can check.
WordPress core has a site health test for persistent page caching, and it has a list of heuristics of headers to look for.
Does it?
Yeah.
Oh yeah, that's a good point. So maybe a starting point would be we could try to query this from HTTP archive and try to see if there's a pattern between those sites that use this versus not in how their time to first byte passing rate looks like. Maybe. One other thing is that's, I hope that's not our only conclusion, but there's the other consideration is that all WordPress plugins that offer page caching still apply the page caching at the application level, which there's also a consideration which that itself still hits WordPress. It still hits PHP. That's still not as good as having a page cache layer at the hosting stack, I guess, which obviously we cannot directly do anything about that. But I hope that that's not the problem that holds us back, right? Like that. But I just wanted to throw that out there as well as a consideration.
Cool. I know we're at time now, so I don't want to keep everyone around too much longer. Just with the kind of 1 minute, are there any sort of concluding statements that we want to make, or just talk about how we're going to move this forward into 2024? Any next steps just before we break off?
As a plugin developer, because that's what my primary gig is, having good tests or validations that I'm doing it right, i.e. the plugin validator, the plugin checker, improving that and sort of beating me up to, hey, you ain't doing it right, good enough, is actually is something that we would improve the overall stock by making it really easy to validate and to check. And we can look at like how much load it comes in and checking and various bits and pieces. More work in that field, I think, would benefit overall, especially if we can do themes as well.
That's good. I'm really thankful, Felix, for you to just diving in and pulling these numbers together. I think it's really easy when we work on this stuff day to day, like over the course of a year, to just sort of get our heads down and like not see the big picture. And I'm just like super impressed with like when you think about the impact that our group has had over the course of this year. Like it's pretty significant, and it's fun to be a part of, and makes me feel good. Hopefully it makes you all feel good.
I think that's a great way to close this session. I think we can all be proud of our accomplishments together with everybody else in the performance team, and let's just keep thinking about what we're gonna do next year about it.
Fantastic. All right. Well, thank you very much, everybody. And watch this space in 2024. Thank you very much. Bye.
Thank you all.
Have a good